Good afternoon, students. So here is this continuation of band theory in solids. So we have been talking about how various bands are being formed in lithium crystal. We have seen how 1s band is being formed here. Okay, 1s orbitals, atomic orbitals are overlapping and they are forming 1s molecular orbital band. 2s atomic orbitals of N lithium atoms are overlapping, or lithium crystal are overlapping and forming the what is called as, this is called as a lithium 2s molecular orbital of lithium, and 2p atomic orbitals of lithium are overlapping and forming 2p band. Okay, 1s band, 2s band, and 2p bands. These are the bands that are being formed in lithium crystal. It is very nice to see here that 1s is forming this complete band, completely filled band, whereas in case of 2s, it is forming half filled. It is just half filled. Whereas 2p, it is 2p is formed, but there are no electrons in 2p, so this is a vacant band. Okay, vacant 2p band. This is nothing but half filled 2s band. This is completely filled 1s band. Okay. Now the electrons that are filled here, half filled in 2s band, can move to conduction band. Okay, 2p is nothing but overlapping band, and it acts as a conducting band. Okay, the 2s electrons go to 2p band and they start conducting. Okay, that's why lithium crystal is a conducting material. Lithium crystal is a conducting material. Now, there is this half-filled band is called as valency band. This empty band is nothing but conduction band, because this conduction band is responsible for taking up electrons from valency band and responsible for conduction of electrons. And that's why this is called as conduction band. This is called as conduction band. This is called as valency band. This is called as valency band. Therefore, now we can see that the materials or solids are being classified into insulators, conductors, and semiconductors depending upon the band gap. Okay, valency band is there, conduction band is there. Okay, if valency band, if there is a large band gap between valency and conduction bands, then it is called as insulator. Then it is called as insulator. If there is a minimal band gap between valency and conduction band, then it is called as conductors. If there is considerable amount of band gap between valency and conduction band, then it is called as semiconductors. Now, insulators. Insulators, now when we see insulators, we are able to see that insulators here, insulators are there here. Insulators, very important. This is an insulator. It's a non-metal. Okay, insulator is nothing but a non-metal. In a non-metal insulator, valency band is there, okay, and a conduction band is there. So non-metal insulator, valency band and conduction band are very widely separated, and electrons cannot be promoted from valency band to conduction band. Therefore, it does not conduct any electrons and it is insulated. Now, in case of conductors, we have already studied that valency and conduction bands, or there is very small gap between valency and conduction band, and the electrons can easily be promoted from valency band to conduction band, and therefore conduction takes place. And the example is nothing but metals. Okay, metals. Lithium is a metal, sodium is a metal in which conducting takes place, and that's why they are called as conductors. In case of semiconductors, there is a considerable amount of there is a small band gap. Okay, between valency and conduction band, there is a very small band gap between valency and conduction band, and therefore electrons can be promoted from valency band to conduction band with rise in temperature. Okay, with very slight increase in temperature, the electrons can be promoted from valency to conduction band. Okay, that is how there is these electrons are being promoted with rise in temperature in semiconductors, and they are becoming conducting at raised temperatures. Okay. Now let us go to next slide. Now here we are able to see the diagram clearly. Okay, whatever we had studied, we are able to see the diagram. This is an insulator, this is a semiconductor, this is conductor. Okay, insulator is nothing but non-metals. Non-metals, there is a wide band gap between valency band and conduction. That's why it is called as an insulator. Now, in case of semiconductor, there is very small band gap. Okay, there is small band gap. There is actually small band gap between valency band and conduction band, and they are conducting at increased temperatures. In case of conductor, there is a minimal band gap between valency and conduction band, and that's why they are minimal. They are conductors. Okay, these are nothing but metals. All right. So insulator, very large band gap. They are non-conducting. Semiconductors, there is a small band gap and they are conducting at increased temperature. Conductors, there is a minimal band gap and they are conducting at a normal room temperature. Now, this is our next slide, wherein we are going to study doping. We are going to study doping. Okay, we are going to study doping on conductance. We are going to study doping on conductance. How doping is occurring in case of lithium crystal. Okay, doping is occurring in case of lithium crystal, and no, I'm sorry, not in lithium crystal. How doping is taking place in case of semiconductors. How doping is taking place in case of semiconductors, and when there is doping, there is conduction that is taking place. With doping, there is conduction that is being taken place. Now let us see how. Let us study how how doping is being done in semiconductors, and they are made conducting at room temperature itself. Okay, at room temperature itself, they are made conducting. The conductivity of semiconductors is very low at room temperature. We all know that semiconductors are very low conducting at room temperature. Therefore, their conductivity is increased by adding an appropriate amount of suitable impurity. Now, their conductivity is increased by adding an impurity. Okay, when we add an impurity, an extra electron is getting added, or an electron deficient site is being created. Okay, this is a very important point. An extra electron is added or electron deficient site is being created. When such a kind of thing is happening, this process is known as doping. Okay, so when we are adding impurity, an extra electron, either an extra electron is added or an electron is removed, and this process is called as doping. Okay, so doping is nothing but the process by which impurity introduced in semiconductors to enhance their conductivity. Okay, so doping is being introduced in semiconductors and their conductivity is enhanced. So it can be done with an impurity which is electron rich or electron deficient. It can be done with an impurity which is electron rich or electron deficient. Such impurities introduce electronic defects in them. Okay, it can be done with an impurity which is electron rich or electron deficient. Such impurities introduce electron defects in them. Okay, which is a very important point. It can be done by adding an impurity, and electron rich or electron deficient sites are being created. Such impurities introduce electron defects in them. Types of doping. Now, what are the types of doping that is being taking place? So we can see here that there are two types of semiconductors. One is N-type semiconductor and another is P-type semiconductor. Okay, one is N-type semiconductor and another is P-type semiconductor. So here, if we see this diagram here, this is a silicon crystal. This is a silicon crystal. Okay, all silicon atoms are there. When silicon crystal is doped with arsenic, okay, arsenic has arsenic is a pentavalent, whereas silicon is tetravalent. Okay, silicon is tetravalent and it is forming 4 bonds with 4 silicon atoms, and arsenic is pentavalent, it is forming 4 bonds with 4 silicon atoms. So silicon here, in this case, silicon is doped with arsenic, which is pentavalent. Now in pentavalent, 1 electron is left out. Okay, this is the electron. This red is nothing but the electron, arsenic atom with an unbonded electron. This is an unbonded electron. Now this is an unbonded electron. Very important for us. This is an unbonded electron. Very important. This is an unbonded electron, and this unbonded electron is responsible for conduction of electricity in silicon crystal. Okay, in silicon is there, silicon, 4 bonds are being formed. Arsenic, it is doped with arsenic, 4 different bonds are being formed, and the electron is left out. This electron is responsible for conduction of electricity in case of silicon crystal. Otherwise, there is no conduction of electrons in silicon crystal. Okay, because there are no free electrons present. All are bonded with other silicon atoms. Since when we are adding an arsenic impurity, which is pentavalent, an extra electron is introduced, and this extra electrons are responsible for conduction in silicon crystal. Now this is another silicon crystal. Okay, here we are able to see this is another silicon crystal, and this another silicon crystal is doped with indium. It is doped with indium. Okay, indium is nothing but it is a trivalent. Okay, it is trivalent. It is a boron family. Indium belongs to boron family. Boron, aluminium, gallium, indium, thallium. Okay, it belongs to boron family and it is trivalent. And when trivalent impurity is doped with in silicon crystal, trivalent impurity is doped in silicon crystal, what is happening, there is a hole that is left here. Okay, there is a hole that is just left here. The important, we can see that it's a hole. Okay, it is nothing but electron deficient site which is being present here. Electron deficient site is present here. Now this electron deficient site is responsible for conduction of electricity. Okay, very important. We are learning that silicon is being doped. When it is doped with pentavalent arsenic, an electron is left out, and this extra electron is responsible for conduction in silicon crystal. Now the same silicon crystal, when it is doped with indium, which belongs to boron family, it is trivalent. An electron deficient site is left here, and this electron deficient site is responsible for conduction. Okay, electrons hop into the electron deficient site, and electrons can move in this way, and that's how conduction takes place in case of trivalent doped silicon crystal. Okay, now so we are able to see here the silicon is nothing but group 4 element. Silicon is nothing but group 4 element. When silicon group 4 element is doped with arsenic, which is group 5 element, arsenic is a group 5 element, there is an extra electron that is left. There is an extra electron that is left, and this extra electron is responsible for conduction. This extra electron is responsible for conduction. Now, when a group 4 element, when group 4 crystal, when group 4 is doped with a trivalent, when group 4 is doped with trivalent, it's very important thing. Group 4 is being doped with trivalent. We are seeing here that silicon is doped with indium. Okay, this is nothing but group 4 silicon is being doped with trivalent indium. Okay, this is nothing but group 4 is doped with pentavalent arsenic, that is here. Okay, now this is nothing but group 4 silicon is being doped with indium. Okay, here it is. Now there is an electron deficient site here. Now this electron deficient site is responsible for conduction of the electricity, because the electron present here can go here, then another hole can be generated here, then the electron present here can go here, then another electron deficient site here. That's how the electron deficient sites are the charge carriers in case of trivalent doped silicon crystal. Okay, silicon crystal. So here we can see. Okay, here this is another diagram. This is nothing but silicon crystal is being doped with arsenic, or it can be stibium. It can be stibium. Stibium is also pentavalent with extra electron, responsible for charge carrying. Now silicon is being doped with boron, either indium or boron. Okay, both are trivalent, and it is creating an electron deficient site which is responsible for conduction of electricity. Okay. Now this is a germanium crystal. Okay, we are studying the same doping with we had seen a slide. We had seen a slide talking about silicon crystal. Now we are looking forward to germanium crystal. Okay, germanium crystal is also a group 4 crystal. So this is how it is, germanium crystal. Now, when germanium crystal is doped with boron, it is creating a hole. It is creating an electron deficient site. When electron deficient site is created, it's a positive hole. The electrons can hop like this. Okay, electrons can hop like this, and that's how conduction takes place. And this is called as p-type semiconductor. Okay, this is called as p-type semiconductor. Since positive sites are being created when electron deficient, when trivalent boron atom is added to germanium crystal, this is called as p-type semiconductor. Okay, this is called as p-type semiconductor. Now we are having this n-type semiconductor. Okay, here n-type semiconductor is nothing but germanium crystal is there, group 4 germanium crystal. Now group 4 germanium crystal is being doped with arsenic. Okay, arsenic is nothing but a pentavalent atom with extra electron, mobile electron. This is nothing but not mobile element here, it's a mobile electron. Okay, it's wrongly printed here. This is a mobile electron, and this electron is hopping, and it is responsible for conduction in case of this semiconductor. Okay, in case of n-type semiconductor, this electron is responsible for conduction in case of n-type semiconductors. Okay, here so that comes to that closes our band theory of solids. We had talked about what is meant by how atomic orbitals are combining to form molecular orbitals, and molecular orbitals of various lithium atoms are forming various bands. 1s band is completely filled, 2s band is half filled, and a 2p band is overlapping with 2s band. And the 2s band is nothing but a valency band, 2p band is nothing but conduction band. Now, when there is a large difference between valency band and conduction band, then it is called as a insulated. When there is a small band gap between valency and conduction band, it is called as a semiconductor. When there is minimal gap between valency and conduction band, it is called as conductors. Okay, conductors are nothing but metals, insulators are nothing but non-metals. Now we had seen how silicon crystal, which is a group 4 element, is being doped with arsenic and indium, and it is forming p-type, and it is forming n-type and p-type semiconductors respectively. Okay, we have also seen germanium crystal, which is being doped with boron and arsenic, and it is forming p-type and n-type semiconductors. Okay, that closes the first unit, molecular structure and theories of bonding. Okay, thank you all for listening, and thank you all for your patience.